So it's my pleasure to welcome this next speaker in our seminar series. I was going to say next month, but they're not exactly evenly month. But this is a real joy. From the time I got here and started to talking to folks around University of Arizona, one of the first things I said to myself is, we got to get David out here. And I have known David, we've known each other for 20 years now, something like that. Yeah. So David is an associate professor at Northwestern University. And as you can see, he holds a whole business card full of other titles. In addition, he's previously been CMIO at Northwestern Memorial. What was your title down at U Chicago?
Also CMIO.
He has launched multiple informatics and built up informatics master's degrees. So he has been doing informatics education way before it was cool. Has done a lot of work in decision support, quality improvement. He's also one of the first people to get the clinical informatics board certification. I hope he forgives me for the questions I wrote on that exam. But today he's here because, what are we hearing most? We're hearing AI in healthcare, and we need to teach doctors to deal with AI in healthcare. And at Northwestern, David developed the digital thread in the med school curriculum. They talked to several people before they settled on it. I looked at the job, said that's too hard. But David has done an absolutely amazing job. I've seen a number of the tools he built and said, oh, we need to get these distributed. These are amazing. So with that introduction, I will let him talk about it.
Thank you. Thank you so much, Justin. I really appreciate the kind introduction.
One more thing.
Oh, yeah.
For all of you out in the ether, please put your questions in the chat and we will address them at the end. So.
Thank you again. And I really appreciate the invitation to come speak. This is very much an area of passion for me. So any opportunity I have to engage with additional audiences, I very much love to do. And everyone has been particularly welcoming here. And so I do have one disclosure I'll mention at the beginning. We have a medical student startup that I'm serving as an advisor on in the AI space. So here, a little bit about my journey to artificial intelligence in healthcare. So a little bit about my background, way back when, in the 80s, received an engineering degree, electrical engineering, and it was a combined computer engineering, electrical engineering degree. 1986, I was also the last class at University of Illinois Urbana-Champaign to use a key punch and a card reader for anyone in the audience who knows what those are. And in fact, they weren't even maintaining the key punch machines anymore. So I had to keep trying to find one that worked. But long ago history. But I've been involved then in informatics education for a long time. After I finished residency at University of Chicago as a junior faculty, I started the first informatics workshops in 1994 with medical students. And until recently, a lot of the stuff was the same, amazingly, like that we've come far in certain respects, but in other areas, some of the basics and things hadn't changed too much until a little more recently. And then pre-GBT, or at least pre-GPT-4, I'll say in particular, several years ago, I decided to, I've been dabbling here and there with coding, I should go in a little bit deeper and started getting in a little bit more familiar with Python. So for those of you who aren't coding, though we might have a select group online and here who do, people tend to think programming is really hard to understand. So Python is actually a great language if you're interested in a hobby other than things like, needlepoint, people love and get their creativity done. Could be very creative in Python and these languages too. And Python in particular, on the right side of the screen, I have a very brief function that calculates a body mass index. And it's easy to name these things in Python. Calculate BMI, and then a little equation underneath, BMI equals weight in kilograms divided by height in meters raised to the second power, and then the function returns the body mass index. And that's kind of like how a lot of Python is written. And one can construct your code in ways like that that's understandable. So if you're interested, and if I piqued an interest for one or two of you who haven't wanted to look at coding, who wants to do that before? And coders aren't going to be replaced for a while. So still an opportunity. There's always going to be need to do some of this stuff. Take a look at Google's acquisition Kaggle, so kaggle.com/learn, and there's a very abbreviated set of lessons, and you can find a little creative outlet to have some fun and see actually things that develop and save them. So I find it helpful in talks often where people kind of say what they're going to say a little bit in review again at the end. So just a few key points to hear at the beginning of the talk that I'll then emphasize during the talk. The educational methods we have at our disposal are greatly expanded with artificial intelligence. A lot of you knew that already, but I'll bring that a little bit more to light. There's various tools like Notebook LM, Colab, others we'll talk about, that are powerful early additions that if you haven't tried out, you should try out. Simulation-based education is really going to gain momentum. It's been hot for a while. It's even hotter and has even much more potential. And then another point, medical education, because we should be thinking about the future for our graduates, must address how artificial intelligence will be democratizing healthcare. And I'll explain that a bit more as well. So a couple things here. Our focus today is going to be on interactive AI in education. A recent commentary that I drafted was commenting on just the overall space within which this fits. And Justin alluded to that a bit as well. So we can think about the total field of digital health education, clinical informatics, everything in this space. Artificial intelligence is a component in our educational spectrum they need to address. So what are the ingredients of this full space? Well, this is where I put this commentary out here, where I address a little bit of the decode framework from the same journal edition, which goes into detail for 19 competencies, 33 mandatory learning outcomes, and 145 discretionary learning outcomes that were assembled from a group of international experts in informatics who said, what constitutes this space? So essentially, there's a big smorgasbord to choose from and pick what makes sense, what one feels is a high priority for graduates of any program that you're involved with, but there's a kind of a nice framework to look at. So now I'll jump a little bit more into the tools that I alluded to. So just to see a show of hands from the room, how many people have used Notebook LM? So there's one hand in the room for the people on the Zoom who had raised their hands. And we see someone online, you guys can see you can raise your hands too. So a hand online too. So I was just on the inpatient general medicine service. So I see patients in the outpatient area and the inpatient. And on the inpatient side, we had a question came up about ECMO use in asthma. And so there aren't a huge number of articles yet. I mean, there's more case reports. This was one of the case series related to use of ECMO in near-fatal asthma. So I used Notebook LM for my team, the usual inpatient rounding team is the senior resident, followed by 2 interns, two third-year medical students and a fourth-year medical student on our team, and created this notebook LM for them with the articles. So it creates a learning guide for key points from articles and also a podcast. And in the podcast, I'm going to switch over here for a moment.
Hey, Jared. Garrett Castra, Bonnie Quine, and Tamana. It's awesome to be back with you all from the Liebovitz inpatient ward for another deep dive.
Always a pleasure.
You know how we're always talking about those really tough asthma cases and how to step up our game?
Oh yeah, for sure.
Today we're going to check out ECMO.
Okay.
And see how it can maybe help patients with near fatal asthma exacerbations.
Sounds good.
The ones that really keep us on our toes.
Right.
So I'm going to stop there for a moment, but what you may not have heard quite at the beginning, it was actually rattling off the names of my team members. And it calls them out by name during the podcast as well. I may not, for a third-year medical student, these are a couple of things that are really important to know. And you can customize it. So how did I do that? All one does on the Notebook LM site. And to let people know, I would encourage you to look at their privacy aspects and security aspects for uploading, as if Google doesn't have access to most of the articles that we're uploading anyway for that sort of thing. But anyway, take a look at that to review it so you know. You can also get the pro version where there's some additional safeguards. But in that regard, you upload a document and then you can customize the podcast for your specific trainees. So I would review the article. If there are a couple key points I want to make sure get highlighted in the podcast, I will call them out in my custom instructions. I'll put the student names in it. And the students on my team, and interns and residents, had never used Notebook LM before. And they were quite caught off guard to hear their names being called out directly while they're listening to the podcast on their way into to work. But I would encourage you to use it. Tools like this are going to expand, and you can think, okay, this is the version now. One can create one's own pipeline to do the same thing, and I'll talk a little bit about that. But you can imagine where this is going, and I can answer more questions about that too. So then, if you haven't used another tool, this tool, have anyone used Otter or the Zoom AI to record meetings? Yeah, I'm seeing a few nods there. So for student lectures right now, if I were a medical student and it was okay with my medical school administration, I would record and I would have those recordings transcribed and create learning guides and study guides and a podcast for me as well. So that then I'm fully supported. In fact, from a medical school perspective, why not do that anyway for all the students? And so you don't even have to have students, you don't have to worry about it. Embrace AI, let the people know, when you're doing it, and there are relationships and subscriptions, and we can talk about this for protecting confidentiality all the way through from a closed loop. So no human other than your approved users actually have access to the information. So and that's how I've designed a variety of the different apps. But this was, what I'm just showing here is a summary. Yuan, your prior speaker, and I had a meeting and a Zoom. And so pulled out a few next steps for David to do things just to make sure I didn't miss anything. But we had AI running during that call. So now with coding, you could say, well, I'm going to be showing you some custom apps. That seems to be like a lot of work to do. Turns out there is a Python. Once you get past those Kaggle lessons, those few Kaggle lessons, a couple weeks at most, could do it in a night if you want to stay up late. But going through those Python tutorials, you're ready to then jump to Streamlit. Now to develop apps in general, there's all the back end, one could have an app, and a front end that a user is using. Streamlit simplifies it and combines front end and back end together. And all one has to do is have this, the straightforward Python code, few little Streamlit additions, but you don't have to worry about cascading style sheets and all sorts of other stuff that adds lots of volume to apps. You just have brief Python code, and all of a sudden, I agree from what they say on their advertisement, they're a faster way to build and share data apps, but I would say data and large language model, a variety of things. Turn your data scripts into shareable web apps in minutes, and that's true. All in pure Python, and they provide free hosting. So the company Snowflake a number of you have heard of, they actually acquired a private version of the Streamlit library, but there's a public version that's available. There is logging in one of the configuration settings for use. You can turn that off in that public version when one's using it and quickly create your apps that are your private apps running locally. And then Snowflake, because they're trying to encourage users, is giving free hosting. And some of the apps I'll show I'm hosting free there. Others I use on a more secure approach that I'll talk about. So here's one of my early ones, back in an early version of the Streamlit app. So for those who are practicing physicians, the audience, we've had a slew of diabetes medications and indications for them. So the SGLT2 inhibitors, the glutamides, the GLP-1 receptor agonist therapies, we've had a variety of things that have come out. And it's hard to keep track a little bit or know precisely what to use when. So as a hobbyist Python coder, figured, this lends itself to if-then clauses really well, a lot of them. Let me make an app that can help me decide and learn about them along the way, because I'm gonna have to make all these clauses. So here, I'm just gonna switch over to the actual app. And let me make it a little bit bigger. So in Streamlit, so here's my type 2 diabetes scenario tool. And when you click options here, these are all tied to the if-then clauses that I've created. If the patient's pregnant, that supersedes everything else in the diabetes management. Some specific guidance comes up. If I remove it, it's say, what's the most recent hemoglobin A1C? If it was 4.81, consider the GLP-1 receptor agonist, because the BMI is still elevated and the patient has diabetes. But if I move the BMI much higher, we got a lot of work to do. Here's some of the things to consider. First, the A1C is over 11. Consider adding insulin with close clinical follow-up, as well as metformin. Consider starting GLP-1 agonist. Consider adding SGLT2, and on and on. So anyway, it's built with if-then clauses. One could do this. It also takes into account ASCVD risk score. And in the slides, I've actually included a GitHub for this, so people can look at the code if they want to and see this. This, by the way, is running on an AWS server that I created years ago and just running low cost. Didn't have to touch it after going in, and it continues to work. So anyway, there's ways to do this in a fairly low cost, low time effort version to actually host it more broadly versus the Streamlit free hosting as well. Now I can't help with my newfound skills. Whenever I read articles, if they don't have an accompanying app to actually bring it to life, it's very frustrating for me as a user. I want to use their tool. So in the New England Journal, inflammation, cholesterol, lipoprotein A, 30-year cardiovascular outcomes in women. So they had all the data that was there. You had to cross-match different tables, use different if-thens, you could come up with actual risks. So what did I do? Of course, I then did it. We actually sent a letter to the New England Journal. They didn't accept it. Even though I showed them the app, we're thinking of sending it somewhere else at some point just to get this out there a little bit more. But we have the app, and I have the app linked here. I also have that I could show, but in the interest of time, we'll just keep going. Works very similarly. Again, one logs in, puts the values in, and you get the equation. Again, straightforward. Once one has these skills, it's actually pretty easy to create that. And to get the skills, you don't need that many skills to make this sort of conversion. Just know the right way to go about some of it. So then we have medical students in coding. So should medical students learn to code? Generally, probably not. Some of, I think, be hopeful, but on the other hand, it's not why they're going to medical school more broadly yet. But we want them to know data science. We want them to learn about AI, and how can we teach them these topics and use AI and other tools in AI-related healthcare education. So I created a no-code app in Streamlit, mostly again pre-GPT, where one can upload CSV files. This one I'm using in the secure Azure repository in the NU instance. I'll demonstrate it in a moment. You can upload files. I'll check the files to see if there's any missing data elements. You do your exploratory data analysis. You could then create machine learning algorithms based on if you have categorical data, you define the categorical elements. And then, of course, I had to add on the large language model with my kind of secure subscription through Azure and OpenAI services where there's no human reviewing it, no caching of the data, and a secure like PHI, like we're using in the clinic now a little bit. Answer questions about that too. But anyway, so it passes through and people can have a large language model weigh in. So here I'll give a quick demo of a couple of things on the Analyzer app. So it's I'll have to probably reload. So, and actually a little bit of the background, this is done with and this, hosting it on Azure is beyond the early coding. You can get an app similar to this working without knowing a lot more that's unfortunately required to get it in a secure way in Azure. For those who are working in this sort of space a little bit, it's a containerized app that's then placed on Azure, and I have other elements of things that are added on for security too. Can scale horizontally and vertically based on usage. So with this, and let me make it a little bit bigger here. So here I have a variety of those test data sets, publicly available data that I've also linked the sources to. So I'll stick on this diabetes one. One can create any, it'll identify in any CSV uploaded or these test ones, is there categorical data, is there numerical data? If so, let's parse those out from your data set that you uploaded. In general, when going through it, I'm going extra faster. Also, first steps, of course, is your data even ready to be analyzed? So I go through a whole series of motions, and if you have missing data, which is common, have a variety of algorithms to fill in those missing data elements, including the multiple imputation through chained equations and that sort of thing, the mice algorithm and others to get just the right synthetic data where your data is missing. So anyway, I'm skipping over that more detail here, but here you see, lots of things you do for exploratory data analysis. You can also create a table 1 for a paper based on your data that would actually, appear here as well. And you can decide what are you looking at. Here we'd be looking at diabetes in this set. You can say whether there's non-normally distributed variables. Anyway, you essentially create your table 1 very easily from the sort of thing. Standard Python, all hard-coded behind the scenes in the app. For a lot of the features, I reveal the Python code so users can have it. And also, this is publicly available in my GitHub for this app. One could clone it, use it locally, then it's all secure in whatever one's using as well. Then in the machine learning, just to go over really fast, students, it'd be nice to know, well, if you have all the ingredients that likely lead to a condition, and you have all the data there, and you know from test data sets whether they had the condition or not, you should be able to derive a predictive algorithm. So that's what I do here. It looks at whatever data set is available, identifies categorical columns here. We'll leave it on diabetes. You could set that within diabetes column, what do we want to predict? We'll predict diabetes. You can decide if you have more options in that categorical column. We could select all the ingredients, all the features to do the prediction here. And then I'll leave it on GBM, but I have a bunch of things there. You can include a fourth spot, which is a little bit of explaining the AI behind the scenes. And so then when I click predict, this is being done on the fly, uniquely just running each time. And here we have our confusion matrix. Most are on this diagonal where we want the output to be. So it's actually performing pretty well. Receiver operating characteristic curve, a PR curve, and then the Shapley force plot and the values as well. And oh, lo and behold, glucose is a major factor in developing diabetes. So kind of matches what we would have thought. So get an idea. And then the last part to highlight on this tool, again, which is on GitHub, and you could work with it, is analyze with GPT. So what I'll put in here is create an interesting plot. So I don't even know what it's going to come up with. So and I have a couple of different ways. I have focused, expansive, 2 different ways in which I'm using large language models. One of them, especially for these public data sets, I'm not even sending the data. I'm just sending information about the data. It generates the code, and then they run the code securely on my Azure site to process and generate the results back. So here's the code that was generated, and then there's the plot, and it created a plot of cholesterol versus BMI, no diabetes, diabetes. Now you could say, if I upload a spreadsheet to ChatGPT and ask it to do it, it'll do that now too. So what's the difference here in this app? Difference is this is kind of explicitly coded in this way. Also, I did this before they made that function available, but leaving that aside for a moment, this is when one does it this way, you're running it locally on your own servers area. So, because I receive the code back and I execute it in the secure Azure environment, not on whatever has been enabled that ChatGPT is doing some of the processing on, or OpenAI. So I think you have an idea of that particular app. So this is a coding-free experience, again, for the students to use. And there's the GitHub and the slides are recorded, and I can also send the full slides so for people who are interested to get as well. Some students, though, really do want that AI, hackneyed saying of deeper dive. So some students do want to take, you can tell it's delve and deeper dive are in text. Probably some AI was generating that text there. But anyway, here, some students would like to take a deeper dive. So we do have a selective in clinical informatics, and they can go into coding. Some of the things they'll get there, in addition to an expectation that they'll go deeper, they have an orange for data mining to instead a series of videos that I've created to guide them through using this open source tool with Python-based widgets. So they're still not actually coding, they're dragging and dropping widgets, but they're getting closer to the code. And then I have a variety of Colab notebooks that I've created. So custom series of 6 notebooks for student trainees that go from the basics of what is a Colab notebook. Colab notebook has some text and some cells where you can run code that can be executed on a cloud computer. So you can run cells and see the code explicitly. So an intro notebook about it, what it is, all the way through to learning about nonlinear activation functions for neural networks. So, and the students in advanced elective are going through these notebooks. And then one of the things, one of the notebooks for the neural network notebook in particular, one of the frustrations I mentioned earlier, when articles are published and you hit all the data there, just like give us a way to interact with it, and they haven't done it. Well, what about if a predictive model is created? That's a little bit harder sometimes to translate from the model into an app. What I did in the Colab notebook is when they create their neural network, they create there's a pre-processing layer for the data that explicitly incorporates, what are the cell name, what are the column headers, and then further, additional ranges for the data element. So there's a pre-processing layer, and then how that data is actually pre-processed. So I save that file. Includes everything you need to do to pre-process a data set like the one you created the model. And then also, students can also download the model. So after they go through the Colab notebook, they can download a file that has the unique pre-processing steps that were carried out on that data set or similarly structured data set, and they have the ability to download the model. Then I created an app where they can upload their own model and it expands. The app incorporates the model. Whatever the data fields were, then becomes available. So in this one, in the diabetes one, for example, in the screenshot, just like these other Streamlit apps I'm showing, it says, okay, one of the columns was cholesterol, glucose, HDL, age, gender, height, weight. So it's already recognizing the column headers, creating the inputs to it, and then creating the model behind the scenes for which those inputs come out. And then you get outputs at the bottom for the prediction result, including a statement. Your model predicts the probability of diabetes is 43% for the values entered. So they can enter any values they want. So now the model is actually coming to life. Just summarizing again, they go through how to create a model. Oh, we got a data set. How do we predict this? Okay, we go through it, goes through all of its epochs and batch processing, creating all the finalized neural network model. We have some optimizations, some other things, hyperparameter tuning, some other things in the Colab notebook. They get through all of it. They got a great model that works. But what do you do with it? Now I've connected this to a Streamlit app. They download it, upload it, and then they actually have a very unique model, because none of these are exactly the same, that they actually can have available as a tool as well. So then a little bit more about large language models. I just hinted at it in terms of the data analysis earlier, but how many of you have used a local language model? From a show of hands, anyone? So one of you has. So you'll get a little to do here, a little how-to in a moment. So what are the benefits? Like, why bother? There's enhanced security. Your data's going nowhere. It's staying on your machine. It's like a complex algorithm that's doing the processing. And there's a variety of front ends available. Orchestrated reasoning is actually still possible. You could do some orchestration of threads of the model and iterate. Negatives of these local models is they're not as smart as the latest version, the GPT, 4.5, the O3 mini, high reasoning, Sonnet 3.7. So those are a little bit more, but they're actually pretty good. They've actually got, and you don't need a souped up computer. This fairly souped up Mac can run like a 27 billion parameter model. But even the ones that are 4 billion, which I'll show in a moment, can actually work pretty well. So here's the how-to for a takeaway. And this is, if you've installed a program, you can do this. And if you have the one little tricky piece without getting into other complexity is you have to open your terminal window in your computer. So that's one thing. So you install this Olama, open your terminal. You can do find terminal or the command window in Windows. And you would type after it's installed, Olama run and Gemma 3. Google just released this model for people to use and download and create apps and do all sorts of things with it. And Gemma 3 comes in lots of flavors. It comes in a 1 billion parameter model all the way to the 27 billion parameter model that run well on this machine. So why bother again, going through these steps? Privacy, security of your own AI on your own machine. You can experiment, and then you can start designing apps at no cost. You're not going to be paying any of the vendors for your tokens, or if things run too long for reasoning, you can just process it, get everything ironed out using a local model that all it needs is your battery that's running on your machine. So and then for the students, I have them in the Colab 6 about large language models. They actually do this on the Google Cloud computer. I have them go through the steps. So that slice of a cloud computer that you get when you're running a Colab notebook, you can actually install a Llama and pull in a language model and run it there, just because Google's giving a fair amount away for free on this sort of thing. They're not giving a super high process machine that you can run for too long. So the demo I have, and also I don't want it to take too long when they're using the Colab notebook, it's the 1 billion parameter model, but even the 1 billion parameter model, again, we're saying 1 billion parameters, so it's like 800 megabytes to download. It's not even that, but it's a kind of one way to think, like a little brain, an advanced neural network there. So here I ask it a question: how is metastatic thyroid cancer treated? And also Google, unlike some unnamed other vendors out there, does have a lot of safety layers in. So like by saying I'm a physician, so no disclaimers, it'll actually, sometimes it won't even want to answer the questions for medical ones because of these other safeguard layers that they put in, but that'll get past it. So okay, let's think step by step how metastatic thyroid cancer is treated. It's a complex area. Treatment strategies, vary, and multiple factors to consider. I cut it off there a little bit. But anyway, there's a fairly detailed, well thought out, not completely correct. It's a 1 billion parameter model, it doesn't know that much. But that being said, it actually did a pretty good job for an 800 megabyte AI, and these are continuing to improve. So something to think about to try, but on your computer, I'll bet, even with a not state-of-the-art laptop, you could get the Gemma 4 billion parameter model running, and that actually has a major step up from the smartness that the 1 billion parameter is actually not bad. So how is education, a theme here, how does this really help with education? Well, and what can these things really do? So I'm going to give you some of the attributes of large language models that we could take advantage of in advanced tools over time. So if then conditions are recognized, and this is really powerful. So I'll give one quick story. When GPT-4o came out, there was a physician at Microsoft who had early access to GPT-4o and put in a really difficult case. Going back and forth with it. And then the model said to him, this was a very difficult and challenging case. How are you doing? So he said he knew he added something different. Tools he used all the time, never asked how he was doing as a user, but these large language models can have a bigger approach to looking at scenarios from multiple perspectives. That's what these state-of-the-art models can do. They can also very consistently recognize if-then conditions, because then you could say, well, if the user indicates any sign of emotion, check in on how they're doing, for example. And then, in fact, use a standardized questionnaire. Give them a link to complete. That then goes out and the result comes back to large language. If the score is above X, send an email to someone else. So there's all sorts of things. It can do, this is codable now, easily done. And the question is, well, is it going to hallucinate? Is it reliable? There's ways to, the latest state-of-the-art models are much less subject to that, but then you include other safety layers on top of that, which would be in your advanced informatics elective to go over some of the approaches that today's quick talk. We can ground it on knowledge so it knows what it's talking about. Multimodal approaches, data analysis we talked about, and then agentic iteration and collaboration. So you almost have a team helping you. So education can be helped from an individual student perspective, having an array of tools available that they can choose to help master a variety of different subjects. And people and the instructors for all different courses should be thinking about how can they use AI for their particular subject matter to best foster student engagement and learning. I'll go a little bit quickly here. One example, in the past, we used to tell students also, you have to put all the information in medical records where they belong, and they still need to do that today. That's going to go away. One of the other apps can process text and pull concepts out consistently. And then you have another layer that double checks the concepts. You could even use M code. You can use specific terminologies. And if this area is there, make sure you're using the same structure that exists in M code. So these sorts of things are possible now. Other ways students can help, well, if they have a question, who can they ask? Do they search into Google, try and search their documents? So this was one of the tools that I created where what's going on behind the scenes, this is orchestrating a variety of actions in a large language model. This one I also have open source on in my GitHub. So in this, what one does is one can put in a clinical question. And here I ask, what's the next step in managing a 56-year-old female with CKD, creatinine 3.5, heart failure with a type O with preserved ejection, A1C of 8, who's only on insulin now? So then what it does, what this particular app does, and how many of you have tried Open Evidence before? Anyone? So Open Evidence is a Mayo initiative where they do similar things, parallel development here, though they have a team and they actually have a company that's been valued at, I think, over $1 billion at this point. But one can code these sorts of tools. What happens here is after you do the query, it will reformulate your query to then optimize a PubMed search. And then I do the PubMed search on the fly. When you have venture capital behind it, you can actually cache a lot of this data, so you don't have to process. It could be a little bit faster on that regard. So this formulates a PubMed search using my NLM, National Library of Medicine, API key that they upped my, with special requests, ultimately they upped my throughput for a little bit for the API key so I could have a number of students be using it at once. So it'll process the query, download abstracts, and attempt to get full text where they were available, and then puts it into a database, a vector store database. It encodes that information, but changes it into numbers, that's important, and then chunks it, puts it into a database. And then it also, in parallel, is looking for reliable internet sites. Reliable, I pre-specified domains, although you can let the large language model choose reliable domains. It's actually not bad at doing that either. And then pull content from those sites and also put it in the vector store. Then reformulate the question to optimize it against asking the vector store to do a semantic search, a meaning behind these words, looking for similar numbers from a semantic search, pulls those excerpts out, and then uses that content to answer the question. So it's grounded in evidence. So this, the way I've designed the app, so best answer from retrieved content, and then additional insights that the model can also provide to help beyond that. And then all of the sources are explicit. They're at the bottom, and can't see it here, but I have all the source excerpts that were available and the actual journals you can click on. You can go and run the PubMed search that was run. And I actually use it. I've updated the app recently from the screenshot. You can actually just use it for PubMed searches. So then you have a much more sophisticated search in PubMed that's done. I also give options for follow-up questions, quick additional internet searches to help answer those follow-up questions. So that's done really fast. And then also expert personas can weigh in on the scenario. So it'll answer the same question from a variety of different personas, custom selected based on your question. So if it's a dermatology question, skin question, you can have a dermatologist weighing in, you might have a pharmacologist weighing in, you might have an internist. But anyway, it's going to customize the specialty perspectives to weigh in as well. So with all of this, is AI going to surpass clinical reasoning? So in April, there was a research letter that looked at, let's see how things do. And let's see how a large language model assess various cases. And let's use a framework that's been established to compare the outcomes. And what they concluded here was that an LLM was better than physicians in processing medical data and clinical reasoning using recognizable frameworks as measured by the RIDEA score. So it's kind of their attempt to identify reasoning that's going on to come to conclusions for what patients might be going on with patients. Then later in October, another randomized clinical trial looked at providing an LLM to physicians to answer a variety of cases. And in that, they looked at physicians alone, physicians with an LLM, and the LLM alone at analyzing these cases. And in this publication, the LLM alone is what did best. Physicians with the LLM didn't do as well. They had a little bit of an anchoring heuristic where they were stuck on what they were originally thinking and not going to get dissuaded even if the LLM gave them the right information. So just something interesting to think about. And the LLMs are going to get better. And they use single pass. For any of these things with patient care, you want to have that evaluation layer. You want to have a double checking layer, make sure the content is created. But even it's doing well even with a single pass at the moment. But for clinical use, my advice until it can be proven otherwise is we shouldn't be using single layers directly and for any patient sort of scenarios for a variety of reasons. But the double pass will get out those, because what percentage failure is acceptable? With physicians, we know humans, we have a non-zero failure rate. LLMs, we're even a little bit less willing if we're going to be relying on that sort of thing. So having multiple layers will even further reduce that failure rate. There have been some publications related to that. So here's another example, case generator and simulator. So I alluded earlier about simulation in medicine being really important. So this is where people can have reinforcement as many times as necessary. You know, when you went into the room, you didn't introduce yourself that well. You didn't really pay attention to what was going on with this patient. You didn't talk about these other things. Let's get a simulation. And you can crank out a bunch of them, and that's going to be almost automatic behavior. Some of us, and I don't put myself in this category, have just the natural skills walking in the room, being really friendly and engaging with all the patients that they see. One of my residents who became the chief residents was just so great on inpatient wards. Most of the patients who leave, they'd be laughing at the end, so no matter what's going on, it's like just connecting as humans in this, even with tough hospital stays and things. He was so wonderful. Most of us, unfortunately, aren't so lucky to have those amazing skills. We can get, a lot of this is learned behavior. And we can, through simulation and simulated interactions, we can see how real is this sort of thing, and I'll show you in a second. So, and here I'm orchestrating a variety of different threads for the large language model. First, you could generate a case, or you can use any of a saved case in a database. There's the patient interview aspect. There's the ordering aspect. You can place orders, do exams, and then you get an assessment. And all of those are under the control of the, a person who created the case to do this. And this is through Azure, container, LLM APIs, speech to text, text to speech, since there's some thought it's a little bit smarter than direct voice to voice, which I've done in some other apps. There are some latency concerns, but it's gotten a heck of a lot better. And I'm not going to, just in the interest of time, I'm not going to show you this one. I'm going to show you a different simulator that uses a little bit of the same technology in a moment. The other thing I was going to point out is, I mentioned Streamlit is a front end, back end combined. So it can go right host. When you get long conversations going, it's a lot that these, even with my scaling vertically and horizontally for these apps to manage, there's the aspect of using an application programming interface. And here I've actually expanded my coding suite a little bit more to the back end. And so I created a back end that replicates everything. So it can be super fast. And all those threads of the conversation can be stored in a super fast database. So this whole thing, nothing needs to do anything more than it was specifically has as a focused action to do. And the whole thing works really well. It works well in the other one, but scaling broadly will this makes it easier, and you can also design your own interface. Here's another interface, looks similar. I happen to use Streamlit for this as a front end, but I could have used JavaScript. It's now interacting with the API. There's less overhead. This even works a little bit faster. Now here's where I'm going to give you the demo again. So with one of the vascular surgeons at Northwestern, Dr. Karen Ho, she was interested in improving education for patients with peripheral arterial disease. And I'll give this just as a use case. It's very focused here, but the implications are large. Let me switch over because the demo is much, I might have to reload here for a second. You reload and you're. And these are password protected, most of them, because there is.
Hi, I am Vera, your knowledgeable guide about peripheral artery disease, PAD. My mission is to answer your questions about PAD.
So I'm going to stop. So this was actually a canned audio. I'm not sure why I cut off for a moment at the beginning, but that's a canned audio that I have for this site. So if people go to the website, that's what they'll hear. But let's get the more engaging aspects.
Thank you so much for calling me. I heard you'd like to learn more about PAD, peripheral artery disease. I'm Vera. Ask away.
Hi, Vera. Is broccoli okay to eat?
Hi there. Yes, broccoli is a great food to eat. It's full of vitamins and minerals that are good for your heart and blood vessels. Eating healthy foods like broccoli can help keep your arteries clear. Are you interested in learning more about how diet can help with PAD?
You know, Vera, I'm here with Terry. Terry has a question for you.
Oh, hi, Terry. I'm happy to help with any questions you have. What would you like to know?
Can you eat meat if you have peripheral artery disease?
If you have peripheral artery disease, or PAD, it means that the arteries in your legs or feet are narrower than they should be. This can make it hard for blood to flow there,
Oh,
which
Vera,
might
let me
cause
interrupt you
leg
for a second. Let me interrupt you. Terry, you may not have heard, he was asking about meat. Can you eat meat?
Oh, got it. Yes, you can eat meat if you have PAD, but it's important to choose lean meats like chicken or fish. These are better for your heart and blood vessels. Eating too much red meat or processed meats can be less healthy. Would you like more tips on a heart-healthy diet?
Yeah.
Go
ahead,
ahead.
Mr. Question.
Can I eat purine-rich foods when I have PAD?
Eating purine-rich foods like certain meats and seafood can sometimes be a concern if you have gout, but they don't directly affect PAD. However, it's always a good idea to focus on a balanced diet with lots of fruits, vegetables, and whole grains to support your overall health. If you have concerns about specific foods, it's best to talk to your doctor. Is there anything else you'd like to know about managing PAD?
Yeah, thanks, Vera. Thanks so much. We have to go.
You're welcome.
Okay. Hung up. So you get the idea. So this, the latency is getting reduced, and this is still with a full pipeline of voice translated to text, text to text generation, the text back to voice again. But that latency is actually pretty good, and you can even interrupt her train of thought. Now in the simulator, it's actually kind of fun too, but then you have the patients with the complaints, and you're getting their history and going through it, and they stay on track. And you can have evaluation layers just to make sure later, but you know, with a lot of prompt engineering, of course, and a lot of double checking along the way, you can, and the latest models behind it, it actually stay on track. And then they're grounded in what you provide as a case creator in the simulator. So this opens up this entire world of possibilities for simulation. And then for patients, before they're going to have a procedure, you have your personalized interactive tool that's going to answer any questions. So cases should never be canceled for inadequate preps or having had something eat or drink too soon. You shouldn't get all those calls afterwards. You can answer other questions and things. Lots of possibility for how this is going to change. Now, finish up here. I'll probably skip over the bitter lesson here from AI, from Rich Sutton, an AI expert, but I want to hit the democratization of healthcare, and then I'll answer questions for things. So the democratization of healthcare, on your iPhone or Android device, you can now download from the 21st Century Cures Act your complete medical record, including notes. So if you can get your notes on there and it's stored on your device, not many people have done it. How many other than me? Probably not many have done it, but you can now. But there hasn't been really value in it. Otherwise, it can aggregate things in the health app. If you have labs at one place and another, you get them all in one. You can do that with some of the patient portals too. But this way, if you have it on your phone, it's not going anywhere, it's just there on the phone. You could then think, well, if I have another app on top of it to analyze it and say, you know, David, you had a CT scan a few months ago and it showed that there was a nodule that required follow-up and I don't see the results yet. Be sure to ask your physician at your next appointment. And that doctor may not have even had access to those results. Imagine where this is going. We're going to have experts at high-level reasoning available at low cost for people to access on their phones, analyzing their medical records at any time. Democratization of healthcare. Lots of implications for this. This is one of the slides I always give the students about a warning about AI. This was the Obermeyer paper from the Optum algorithm that was implemented in many hospitals, where unfortunately we were ultimately worsening healthcare disparities as a result. We have lots of active AI projects at Northwestern, which I can answer questions about later. But the key points at the end, the same as at the beginning with one addition. With all of these changes, with democratization of healthcare, with these tools that are helping, we have one more key point here. Our new trainee goals, renewed, I should say, trainee goals, because these have always been important. Emotional intelligence, empathy, critical thinking, I should have here too, intelligence, empathy, effective communication, and lower down is the expertise, because there's going to be unassailable, unimpeachable expertise available to everyone at every moment for everything about their health. Taking all those biomarkers, everything else in consideration from a paper previously in the week, appropriately interpreted and applied to their health. This is the world we're going into. So it's these other soft aspects of healthcare that are most important that our trainees need to have. And then they need to retain critical thinking and all these other skills to then leverage this technology to be effective clinicians. Then let me stop for questions. Justin.
So I'm a skeptic. What's your response to the Hager paper in Nature Medicine late last year that showed that, yes, if you give AI a complete case, they're awesome at reasoning and better than humans. But if you make them do it the way the doctor is, give them a piece and then ask for the next piece of information and do it incrementally, their performance drops by half.
Yeah, a couple of things. I would say that the models are improving substantially. And there's also evidence that just like in physician studies that we've shown, there's having more physicians weigh in leads to better decision-making from a human perspective. That's also been replicated in some studies, but for really complex scenarios, more models adds more confusion potentially. But for most of what we do in medicine, my answer to this is not super complicated. And the next steps are relatively clear if the data is fed in a consistent, appropriate longitudinal way with appropriate pre-processing and appropriate monitoring and getting consensus. You could have 3 independent models, slightly different methodologies, and look for consensus for those next steps. So bottom line, yes, I think this is a risk and there's going to be lots of failure modes. Each of these failure modes, just the way I see this is going, are going to have solutions. Current generation, we are not there, is what that says, and I agree, we are not there. But the tools and techniques are available, we will be there. And that's what we need to be training our students for.
Yeah, thanks, David, for a really interesting talk, especially. I'm actually planning probably to have a lab meeting where we try to teach some of the students how to use some of these tools after I learned them some more. It kind of reminds me of like when the internet first started, there's like all these different word engines, right? Like Yahoo and everything and Google. If I were to get started, it seems like for a lot of these, I could upload a subset of like our lab's research and have it summarized, and that would be something helpful for the students. How do you decide like what tool is best? Because it seems like they all could do that, right?
Right, so I guess I would look at, the difference is if one were to use any of the near state-of-the-art models, nuanced differences almost doesn't matter.
Okay.
Whatever, if you have some starter educational funds from one versus the other, that sways the decision. But similarly, I'd even encourage you to experiment with the local models and the DeepSeek latest reasoning model, the Gemma 3 model, and actually the DeepSeek, to download the full DeepSeek, unless you have computing infrastructure, you can't use it. But that's like the 650 or whatever, or 605 billion parameter model. But the distilled, where they kind of teach other models, like Llama on one of the Llama models on the output of DeepSeek, those are downloadable, 70 billion parameter model. That'll actually run on my Mac. So those sorts of things you can do, and those are pretty good. And you could, or Gemma 3 at that 27 billion parameter I alluded to earlier. You can do a lot and generate all your apps. Data's going nowhere. You don't have to worry about the privacy concerns, and you can kind of try things out, and you're going to get close enough where performance is good. And it would take it's going to take a step up when you get all the security agreements and everything else to use one of the other APIs. But I'd say experiment with the local for the tools. Okay.
So just for those of you local, literally everything David showed, there are workshops that are open and free to your students. And you can go to the Data Science Institute, click on Data Lab, and even the infrastructure to run it, including DeepSeek, which by the way is banned by a university starting yesterday.
Yeah, my coworker just texted me that he's watching.
But we have the full version running elsewhere, and you have API access, so come see us if you need it. So David, first of all, I applaud the amazing journey you've taken to be where you are. And if we don't encourage people to play with AI, they're going to sort of not shape it in the way they need it. And sometimes people feel because they're alone or they're one person, if we all collectively don't get our hands around this, the technology is going to be pushed down our throat without the customization that we need. So I'm really excited to see what you're doing. So my question, it's a two-part question. The first is, our reliance on models, doesn't matter which they are, especially like the commercial ones, they are going to change the model and they want you to move to the new model because they deprecate things. And in my experience in the past, especially working with law enforcement, where the companies will swap something and then some things get worse than others, but you're never told what it is. And all the benchmarks are global on something. And it's not, as a physician, your set of patients are testing against what you have. So as time goes by, you are inheriting some technical debt where the things that worked a few months ago or few versions ago are going to be worse, but you're doing new things. So how do you sort of reconcile like the new models, the new features, but you don't know what you're giving up? So that sort of is the first part. And the second part is, do you feel each of us should have our own laundry list of quality control levels that we run anytime somebody says, this is a new version, you're like, I'm going to test everything I care about. And if it meets that, I will adopt. So it's a two-part question.
Yeah, no, exactly. Though your second part kind of answers what I was going to do the first, is the evaluation layers are really important. So working to have a set of metrics that you can follow so that your system is performing as expected, with a series of edge cases and typical use cases that have been arranged for based on how people have been using the system. Save those from real use and then score them. So save them, score them, have your own evaluation suite. And then when the new model comes along in your pre-production server, in your development server, which is running exactly similarly in parallel, which I've done for the various apps there, you switch out the model and you look at your evaluation metrics. And if it meets muster, then and only then switch. And if it doesn't, you work with the vendor, you get some other, model that will continue to meet muster if the other one ends up being deprecated. But you're right, it's changing so fast. The models come out. And actually, I also just want to, so you have, just to clarify a little bit, do you have the full 600 billion parameter DeepSeek running? So that's great. So most places do not have that. That is a phenomenal resource that your team has been able to create here.
So I should thank the Indiana University that has a $250,000 server that's running it.
Okay.
But it's a common grant, so
Got
we
it.
have access to it. Anybody at the UFA with their login is able to get in and use it.
We do have 2 questions on Zoom.
Sure. I'll take a look and then we'll come back to the room 2, time permitting, and I'll also be here for chats.
Yeah, so.
Oh, yeah, for the, thank you, let me scroll back. For PAD, how do you train it to ensure it's comprehensive, accurate, reliable for the PAD tool? So personally, so there, essentially what we do, for this one, it's a little bit of a, you know, it doesn't have all the layers that I would have in the full production version, but what we have is an evaluation layer. So all of the interactions that we were talking about are assessed. And if it doesn't stay on track or it's giving erroneous information, we're going to be able to call that out, at least from another model's perspective, which is also grounded in data. So we have ground truth that we're giving it. Here's what you should use about vascular disease. This is your information. If it's outside that, you say you don't know it, you apply your vascular knowledge to address and answer the questions. And so that's essentially how it's designed. It's been grounded first. We're not using the model's inherent knowledge, assuming it stays on track. And to make sure it stays on track, that's where we have an evaluation layer in place. This is not perfect, but it's kind of where we are now. It's continuing to improve. The other one, in the Llama models, are you downloading the fitted train model or am I training it on my own machine? These are already trained, ready to go models to interact with. You can then further, there are actually opportunities. My machine might just be up to some of the fine tuning for some of these models, but you need souped up machines to be able to do the fine tuning. You can do prompt engineering. You can do multiple calls to the model to assess the accuracy of the response. Those options are available with them, but they're really fully done, ready to go. So thanks so much. This was great, and I'll answer other questions if people want to come up and chat.
Thank you.